Okay, so I really have no idea why I do this thing. Okay, anyone remember? Is it like I say like what before and after? Oh, all right. Is it like very difficult? I think so. Okay, something like that. All right. So anyway, today is an exciting day. You know why? Because what's today's date? Today is the 10th of March. And what else? And the weather is fine. Okay. What else? Next week holiday, right? Holiday, so 1 week holiday for y'all. And of course, it's exciting because we're gonna go through this. It's a before and after. Now, before and after is before I start. Okay. It's the thing that make me do math problem sum super duper fast. Okay, this is the like my super what do you call that? Secret. The secret of my ability to do math problem sum. Why do I say that? So before I learned before and after, I was only using model. That means every time I see a difficult question, I'll be like, oh, hey, okay, draw model. And all the models, they cannot solve questions that are related to before and after. Okay, have you encountered questions where no matter how you draw model, no matter how you go and draw the model, somehow it just doesn't make sense. Somehow it just doesn't fit, and you do not know how to continue. Have you encountered something like that? Yeah, Kristen, have or not? Yes, right. Or you I like your Batman mask, you know. Batman mask. Okay. How about Kenny? Have you encountered things like that? Like problem sounds like that, right? You no matter how you draw the model, you try to chop here, chop there, you know, put one here, there. You just cannot figure out how to continue. Okay. So then after that, I came across this thing called before and after. Now I did not invent before and after. Okay, before and after has many names. Some of the name is called internal transfer. Another name is called external transfer. Okay, have you heard of this? Okay, so actually you see this external transfer, right? External with unchanged quantity concept, all this stuff. I did not invent all this. Okay, before and after. Is actually MOE that stated all these things. Okay, it's under, if you don't believe, I mean, y'all will believe me. Just saying, if you are really free, right, you can go to the MOE SEAB website. You go and download. What does every P6 student need to know? So one of it is heuristic, right? Under the heuristic, there is before and after. Okay, so I look at that and oh, no wonder they test you all this stuff, right? It's because you need to know before and after. Okay, so after I learned this thing, suddenly that was many years ago, at least 8 years or 9 years ago. That means you see, I've been doing this for 14 years. That means for a good 5 years, I use brain power. That's why my hair dropped so much. You see, do you want to drop hair that much? No, so don't use brain power. Okay. Then after that, I found out before and after. Suddenly I have some hair left. If I didn't learn this, you know what's gonna happen? My hair is gonna look like that. My head is gonna look like this. Okay. So all blank one. It's terrible. So luckily for before and after, I managed to save some hair. See? So whoever discovered this thing, right? I want to thank that person, okay, for saving some of my hair. Anyway, let's cut the story short and go in, right? So this one, right? Before and after, there are 4 types of before and after. Now, if we were to refer to the very beginning, which is the page with this one, with all the different heuristics, right? What are the 4 types of before and after? Let's take a look here. So the first one is called before and after single unchanged. Second one is called before and after total unchanged. Okay, next one before and after difference and the okay, all these 3 are, I would say, difficulty level 6 upon 10. Difficulty level 6 upon 10. The last one before and after units and parts. All right, this one go bonkers. Oh, now I know how I draw the person. Right, you go bonkers. Right, this one. Okay, this is the question that this type of question, right, are the ones where most people will cry one. Right, so I remember many years ago, I think 2009 or over which year, there's 1 year where a student actually cried during the actual PSLE, after the PSLE, of course. Okay, why they cannot solve the question? And guess what type of heuristic it was? Units and parts. They did not only give them units and parts that year, they even gave them before units and parts and mixed together with equal concept. That means there were like 3 different heuristics in one question. Okay, let me see if I can find the article. Student try after ESLU 9. I think it's still year 9. Don't put the year. This one, see, 2019? No, 2019, right? Some other year. Are there? This one. Students cry over unbelievably hard PSLE math. Remember this? Because when I tried to do the question, I couldn't do the question. I was like, why ask stuff like that? Okay, so it was slightly difficult, see? James, yeah, local tutor. This is not Mr. Ting, okay? James, I don't know who's James. So then it was so bad that the MOE had to come up and explain. Okay, so what was it? Oh, it's because now I let you all use calculator, ma. So I can ask very difficult question, ma. You understand? Does it make sense? Because previously no need calculator, they cannot use calculator, right? So now, yeah, so now that I let you calculator, then it has to be tough. Okay. So you see, MOE will turn out more and more curious. What is this? Right. So they're going to tackle more difficult questions, right? So are we going to see this particular question? The answer is yes, right? I will show you what it is, but I don't have it here right now. Okay, students cry. They cry. It's bad.
Why did I student cry? It's such a big deal. Cry?
Because I don't know. Alright, so do you have to cry? No need to cry. Okay. Let's say even if you don't know how to do one, it's maybe maximum 5 marks, correct? Just skip lah. You understand? No need to cry.
At first, right? Yeah. Studying the paper, I skip like 10 questions.
10 questions.
I forget how much I get if I did 5 questions. Then 7.
Yeah. Then let's see. Can you see 2009, right? So this is the one. It's the year 2009. Okay. See, I remember correctly. 2009. It's a parents were so upset. Okay.
Why?
Well, because they say that my child prepared for so long, then you give me such a difficult question that nobody can do. Okay, she came out the gate and started crying. So sad, I lost confidence. Why make it so tough? I wanted to join it, the complacent. What was it? Okay, they don't have the question here as well. So what did they do? The journalists, right? Because it's so ridiculous, right? The journalists took the question to ask a lot of people. They ask secondary school students, don't know how to do. They ask JC students, don't know how to do. They ask poly students, don't know how to do. University, don't know how to do. They ask teachers, some teachers don't know how to do. Tutors, adults, all don't know how to do. See? Yeah, then how come, why you let P6 students do? You know, there was a very big question mark. Okay, so after that year, MOE became very conscious of what type of question they said. Okay, they're like, okay, better not give such ridiculous question. Like, I will show you what this one was, right? Really, it's ridiculous. It is a okay. I have it somewhere here, right? So, but I need to go and search the thing. Wait, it's in my other board, I think. Yes, sorry. Long time ago already, right? I'll probably have to go and. No, almost every year I will take a look. And it's about. Let me think. It's about chocolate and cookies one. Let me search whether maybe it's faster here. Here's a math question. Half chocolate, half sweet. Okay, let me see this here. See, they all nice. Because this is the one. So a lot of people started giving answers, and then say, see, I know how to do, Oh, okay, use algebra.
Wait,
this is the question. Yeah, it's only like that. This is the question. It's only few lines. That's the entire question. Okay. Look very simple, right? Okay, never mind. No need to try and solve here, okay? So this tutor, Ayumi love, must use algebra to solve.
Really?
Then that's what she said, right? Use algebra. Oh, look at the working. How about guess and check, right? So also can use guess and check. Mentally, modeling, right? So super duper long. Okay, so this was the one that people cried.
Do you know how to?
Yeah, okay, at first I don't know. Honestly, I don't. I look at it and think, what? I don't know where to start. Okay, but this one is an example of this. Oh, let's go back here. This one. Before and after units and parts. Okay, and mix together with other equal concepts. Okay, it's mixed with equal concept and other stuff. Right? So that time, if the person knew units and parts, okay, maybe he or she will be able to solve that question. Yeah, because they understand, hey, it's just heuristic. But honestly, if it was me, yeah, and I see this in the exam, maybe I will just do 1 or 2 marks, you know, get 1 or 2 marks, and then I'll move on already. Move on to something.
The last question.
I don't remember. Right. So this was a killer one. 2009. Okay, that year. So many comments, See how many comments? What? Okay, a lot of people gave solutions. Many people gave solution, right? Good. Okay. All right. All right. So let's come back to here. Okay. So what I'm going to do is going to start from beginning, which is this first. Okay. Before and after, single and change. So let's go back to our question. Question is here. Right, we'll start from easy one. Easy one, So sure.
How come like the student will cry, right? When they cry after, they not cry during the paper.
Because during the paper they are concentrating. The tears cannot come out yet. Or maybe dry already. They're too busy to cry. It's only after the exam when the time stopped, right? Then they realize, oh no, they say I don't have an answer, and they cry. Yeah, I don't know. Okay, no need to cry. Actually, doesn't matter.
I'm very used to not having an answer.
Yeah, but maybe some of them they always have an answer. Okay, so I don't know. All right, so let's move on with the first one. Okay, so the first one is now we call it external transfer with unchanged for it. It's actually single and change. Okay, you can call it single and change. Why do I have two names? Because some schools call it this thing. So I want to put it here, just so you know. Okay, that they are the same stuff. Right, so what's this all about? Let's take a look at the story, all right? So Cindy and Jin Xian shared a sum of money in the ratio 2:5. Okay, let's just take a look at first sentence. Cindy and Jin Xian share money in the ratio 2:5. So what I'd like to do is, I'd like to have Cindy here, right? And then after that, Jin Xian. Okay, let's just use the alphabets. I want to write the full name. C and J. Okay, so their ratio is 2:5. Now this is B4. Now I write B4. B4 is short form for B4. Okay? Right? B4. Now second row is what I call plus or minus. Okay, second row plus or minus. Now third row is after. So let's look at the ratio after. So before whatever thing happened, right, the ratio was 2:5. So after Cindy spent 45, the ratio became 1:3. So what is the ratio after? 1:3. So, but how much did Cindy spend? 45, right? Do you see this? Cindy spent 45. So Cindy must minus $45. Right? Okay, so the idea is just fill in this table first. All right, so this is called the before and after table. All right, so beforehand, ratio between these two persons is 2 to 5. Cindy spent $45. After that, ratio becomes 1 to 3. All right, so in this particular story, okay, there is something that you need to realize. You need to realize that the amount of money that did Jin Xian spend anything? Did Jin Xian receive any money? What does it mean if he never spent anything? Yeah, that means the ratio should be the same. Okay, but you see that here is 5 and here is 3, right? So I'm going to use another color. So by right, what I need to do is to make this the same, okay? Because Jin Xian never do anything, so J, what's the common multiple between 5 and 3? 15. I should make this 15, 15. Then I can compare this person, right, Cindy. So if this is 15, that means here must times what?
3.
Yeah. Now ratio means if you times 3 here, here also must times 3. All right, so 2 times 3 equals to 6. All right. So how about here? Times 5, right? So here also times 5. So this comes 5 to 15. So now let's examine the ratio before and after. So the ratio before is 6 is to 15. The ratio after is 5 is to 15. And this is after Cindy spent $45. Okay? Right? So what can you tell us about the $45? Ah, correct. So 1 unit represents $45. Right? How about how much money did Jun Xian have? 15 units. So 15 units. You can use your calculator here, okay? You have to use your calculator. 45 times 15. 675. So that's the answer for question 1. Okay? And you see this is a very elegant solution. Elegant means yeah, not very messy. Okay, don't you draw too much stuff. So just like that. Is it easy? Does it make sense? Must make sense for everyone, huh? Right, Kenny, is okay? Does it make sense? Okay, so what do we do? You have to identify who never changed, yeah? So in this case, J never changed. How about part question 2? So a box contains some red and blue in the ratio 2 is to 5. So I write it here. So I write before plus or minus and after. Okay, so I have 2 types of marbles. There's red and blue. So at first the ratio is 2 is to 5. So after 44, blue marbles will remove. So here minus 44. The ratio after became 3 is to 2. Okay, which one never change? Red. How come red never change? Winston, how come red never change? How do we know red never change? Right? How come we know red never change? Must read the story. Which part of the story say red never change? Did they say anything about red? So if they never say anything, means never change. You understand? You understand anything? Right? They only say, oh, they removed 44 blue. So red, they leave it there, right? So what do we do? We must make red the same, right? So red and blue, right? So what's the common multiple? 6. So here must times 3. So here also times 3 become 15. And this times 2, 6, so 4. Okay, so this 44 is here, right? So 44 is actually equal to how many units?
11.
Yeah, so 11 units represents 44 marbles. So 1 unit is 4 marbles. So why? Okay, what's the question? How find the number of red marbles in the box? So how many red are there? 6 units. Okay, final answer is 24. That's it. So that's question number 2. So far is it easy? No. First one easy, yeah. Before and after single and change is one of the easiest. Okay, so have you done this before in school? P5? Don't remember. Okay, never mind.
Maybe during circuit breaker because like
Hmm.
circuit breaker like other people are
Online.
online.
Online,
Yeah,
right?
once they
HBL.
like the video, like
I
they
see.
like try to make sure that they were always on the phone.
It's okay. That's why I must revise. Okay, so revise it, right? All right, so we're done with question number 2. Now, can you all just try 2 more? Just try 3 and 4, and then we check. Okay. So you gotta be careful. You see here they put a fraction, right? And then got this is a percentage. So just make sure you know how to change them to units. All right. So for example, percentage of horses drop to 30%. That means sheep must be 70%. You understand? All right. So another example, if there were 4/5 as many sheep as horses, that means sheep is 4 and horses is 5. Right. So you gotta deduce all this yourself. Okay, can you try 3 and 4? Try 3 and 4. And then later we will take a look. Okay, pause. Okay, let me help you with the table. Right, you might be wondering how to do this first. So on a farm, there were 4/5 as many sheep as horses. Okay, I really like to draw, but I don't think I can draw. I don't think you'll be able to tell the difference if I draw sheep and horse. To me, they look the same. Right? Hey, wait, what? Oh yeah, my mouse. You see, my mouse also agree with me. It's like, Mr. Ting, please don't draw. Okay, before, plus or minus, and after. So what do I have? Sheep, letter S, and horse, letter H. So 4/5 as many sheep. What does it mean? That means for every 4 sheep, there are 5 horses. Okay, 4/5, 4 sheep, 5 horse. So after, oops, 92 horses were sold. So we minus 92. The percentage of horses dropped to 30%. Okay, so this became 30%. Now, if this 30%, how many percent is it?
100.
Huh? No, 70. 70, right? Because these two together is 100. Okay, so now you look at this. Hey, I have a problem. This is 70 and this is 30, right? How to, I want units. I want to make them units. So how to change them to units? 7 is to 3. You see that? So I remove this. Right? So this is 3. Okay? And then you look at this. Hey, this reminds me of a question that Mr. Ting said before. Right? This looks like a before and after because there is before and then something happened and then there's after. Okay, and it is a single and change because did anything happen to the number of sheep? Nothing happened, right? I'm going to draw a sheep. Tell me if this looks like a sheep. Can can pass or not? Can. Can. Yeah. See, I practice drawing every day. All right. Alright. Okay. See, sheep, right? What? Okay, I have 2 dots enough already. Okay. So they say the shape never change. She never change. Not sheet. Sheep never change. Okay. I'm gonna draw sheep too. Right? Sheep never change. So if the number of sheep never change, I need to make this the same. So how to make this the same? What's a common multiple? 28. Yeah, very good. So 28. Okay, which means here I need to multiply by 7. So it's 35. And this times 4, right? So it's 12 minus 92. Okay. So how many units? What's the difference in terms of units? 23. So 23 units represents 92 animals. Now 1 unit will be 4 animals. Okay. So what's the question? Number of sheep on the farm. 28 units, right? So we take 4 times 28, 28 times 4. 112, right? So there are altogether 112 sheep. You get that?
Why you doing the number of sheep?
Just to emphasize, okay? There are 112 sheep. Easy enough. It's okay. It's very easy if you know how to do. But if you don't know how to do, I look at this. Wow, I draw model here and there non-stop. It's very difficult to do. Okay. So it's 112. Right. How about question number 4? Did anyone do? Have you done? Have you done? Have you done? Don't know. Okay. Maybe I start something first. Okay. So in a class, 40% was spectacle. Right. So 5 pupils left. Okay, so if 40% wore spectacle, how many percent didn't wear spectacle? 60. So let's do a before, plus or minus, and after. Okay, so wore spectacle, I'm going to draw a spectacle. Specs. Alright, no specs, how does it look like? Just eyeball. Okay, no specs at all. Okay, so 40%, that means this is 4 and this is 6. Right? 5 pupils left. What wore spectacles? So minus 5. Then the ratio, the percentage of pupils who wore specs dropped to 30. So this one 3 and this is 7. Okay. So what is the number that never changed? Huh? The number of people who don't wear spectacles, right? This one remain the same, right? So I'm gonna draw the specs again. Right, eyeballs. Okay, so what's the common multiple between 6 and 7? 6 and 7. Can you do? Continue. You continue from here. Continue from here. Right, already done this part. Okay, so we change to 42. This 42. Also 42. So here times 7, right? 28. And this is times 6. So it's 18. So minus 5. Okay. So 10 units represents 5. So 2 units represents 1. Okay. What's the question? How many pupils in the class did not wear spectacles? How many? 42, right? 42. So it's 21. I think it's 21. Okay, this one do you understand? Like how to get the number?
Yeah, because I put 1 in 0.5.
Oh, 1 in 0. Also can. If 1 in 0.5, so here you just times 42. 0.5 times 42 is 21. Can be done. Okay. Okay. Copy first. Now do the next few. Okay, I'm gonna let you do the next few. Alright, you all gotta do yourself. I'm gonna stop. Yeah. Alright, that was some show, yeah. Alright, so let's take a look at the next one. Question number 5. Okay, I'll draw here. So Karen had twice as many stickers as Julie. Okay, let's check what answer do you have for 5? 7, 150. How about you?
150.
Princess? Huh? 5? Got answer for 5? No? Okay, I must keep asking one, because I must learn how to do one, okay? Okay, let's see. So Karen had 3 times as much as Julie, so I will put before plus or minus and after. All right, so Karen versus Julie, 3 times. Okay, 3 times twice as many as Julie. So Karen used some, she was left with half as many as Julie. So if Karen had 30 stickers left, so actually this is actually quite easy, right? So there's 30 stickers left. Hers is half of whose? Karen was left with half as many. So if Karen had 30, that means this is 60. Okay. Now because Julie never changed, right? So if Julie never changed, that means here must be 60, right? Okay, so this is 30. Now for 1 to become 60, must times 60. So 3 times 60 is 180. Okay, so this 3 times of this. So how many did Karen use? Minus 150. Got it? Okay, so she used 150 stickers. Okay, next one. Okay, among the 1,002 participants who attended the education, 1/3 were male. Alright, so I have male and female. So male and female. 1/3 male means 400 are male and 800 female. This is before, plus or minus, and after. Right, see the template is always the same. Then what happens? Some female left, and the ratio of male to female became 2:3. So male to female became 2:3. So this minus sum, I don't know minus how many, right? Now what answer do I have for this?
450.
450. Same, Vincent? Oh, your Vincent must go back and check all your answer, okay? You must check all the working note. Alright, so M and F here. So you see minus something then became that. So which one never change? Male never change, right? Male never change. So I should make this 400. So for this to be 400, must times 200. Correct? So here becomes 600. Right? And this was 800. And this was 400. What's the question again? How many female left? Wait, what's the answer?
450.
How come you get 450? Is it 200? Wait, double check. 1/3 were male. Among the 1,002 who attended, 1/3 were male, some female. So if 1/3 male, so 400 male. So female is, yeah, 1/3 were male. Among 1,002, 1/3 were male. What's 1/3 of 1,002? 1/3 of 1,002. That means 1,002 divided by 3. It's 400. Male is 400. Oh, no. 1/3 were male. 1/3 were male participants, right? Out of the 1,002. So this is a English comprehension. This is English comprehension, right? So 1 out of 3. It's not 1:3, you know. This is 1/3. 1/3 were male.
So it's 400.
Yeah, so it's, look at this, so it's 400. Therefore, the answer, how many females left? 200. 200 females left. Okay, so it's 200 here. All right. Next one, question 7. So Mrs. Lim baked some round and square cookies. 40% were round. So Mrs. Lim, so we have round and square cookies. So this is before. Right, so how many 4 units here round and 6 are square. So she gave away some round plus or minus. So minus question mark. Okay, after that, the percentage of round dropped to 30%. So this became 2, this became 8. Okay, she was left with 120 cookies altogether. So what is which one never changed? Square one never changed, right? So round, square, common multiple, 6 and 8, 124. Also can, doesn't matter. Smaller number, right? So here times 3, times 6, times 4, so it's 16. Right, so, but here, she was left with 120 cookies. So this whole thing here is altogether 20 units. So this is 24. So 20 units represents 6. So the question is, how many round cookies did she give away? Here, 10 units, right? She gave away 10 units. So 10 units equals to 60. So she gave away 60 cookies. 60 cookies. How come? 60. 10 units. Question 7. This 20. 32 minus 20. Okay, copy please. Person must label, right? Then you know which one is which. This is. Next. In a game of tug of war, there were 40 people from school A and 20% more pupils from school B on the other end. Okay, so we have school A, school B. Alright, so before school A has 40, school B is 48. Do you know why? Why is it 48? Because you must find 20% of 40. 20% of 40 is 8. So there are 48 pupils in school B. So then what happened? Some pupils from B left. So minus some pupils. The ratio of number of school A pupils to B is 5:4. Question mark. 100. 20%. So I got 5:4. So which never changed? School A. School A didn't change. So to try to make, try to make school A the same. So A is to B 40 is to 48. Now here to make it 40 times 8, right? It's 40, 32. Alright, so how many pupils from school B left? Here we go. This answer. Okay, 16. left. It's time for you to do again. Okay, so this is first 8 question. Now you should try the other ones now. Okay, so there's an error here. 6 plus 24, I thought it's 14. It's bad handwriting. This is 24. All right, so this altogether is 30 units. Okay, 30 units 120. 1 unit is 4. So 10 units is 40. Yeah, my handwriting wrong. Wait, do you get 40? Oh no, Kenny, so sorry. All right. Okay, so it's 40 here, right? Okay, wait, we look at 1. Alrighty. So Sean has 60 fridge magnets, 40% are triangle, rest are rhombus. So we can actually find out straight away what's 40% of 60. Because altogether they are 60, right? So 10% is 24. So triangle ones, they are 24. Rhombus. How does rhombus? Oh yeah, don't draw rhombus. Rhombus are. Okay, now if 24 of them are a triangle, how many are rhombus?
36.
Yeah, so 36 rhombus. Okay, this is before. After he gave some triangle magnets away, so minus some question mark plus or minus. Okay, minus some. The percentage of triangle dropped to 20. So rhombus should still be the same, right? Rhombus never change, right? So here should be 36, right? Now this is 20%. Here,
20% of 24.
no. Drop to 20%. Now if this is 20%, that means this is 80%. You got it? Here is 20%. Alright, so how do I find out what is this number? Just divide by 4. So 36 divided by 4, this is actually 9. Because 80% is 36, right? 20% is 1/4 of this one. 1/4 of this, right? So this is 9. So how many triangle fridge magnets does Sean have in the end? We saw the answer already. It's 9. I didn't do any more things. Okay, there are 9. Vincent, do you get the table? This one? Oh, you didn't get the table. Draw the table. Next. Okay, draw this table, right? Triangle, rhombus, and these are the numbers. Okay, next one. Kim had a box of apples and oranges. The ratio of apples to orange was 1:2. Okay, let me draw the. Sorry, we'll draw quickly. So apples to oranges, 1:2. Now, when 56 more apples were put in, so plus 56, the ratio number of apples to orange became 9:2. 9:2. Okay, so which one never change? Oranges, right? And just 9, here it's already done. It didn't change oranges. So how many apples were there at first? So here the difference is 8 units. So 8U represents 56. So 1 unit will be 7. So how many apples? 7. You got 7? Yeah. Okay, you got 7? Vincent? No. Okay, you gotta go home and do all. Okay. Vincent must redo everything, Vincent. Right? All this, draw one sheet for me also. Okay. Go and do all. Alright, so I don't have homework for you. Alright, we will come back next week and we will continue our before and after journey. Okay, now yeah, so before and after journey is a very, very long one. Okay, it's a long journey. See, we are only at this, right? Basically, all of them, right? Not all, I would say until you see, it's still here. At least for the next 10 more worksheets, right? They're all before and after. See, here is still, oh no, this is also before and after. Something like before and after. Here. Until here. No, this is proportion. Yeah. 7. Skip it. Never mind. Because we change as we go along, some heuristic will take it out. Alright. So yeah. So you see, it's a long journey. Alright. So today is just a starting. Hopefully you have an idea. Okay. Or before and after master how to do. If you, but the thing is, if you know how to do before and after,